so week 11, we're going to start vegetative reproduction. It's really weird not having you here. I'm sure it's weird for you as well. We're doing the best we can with the situation, but I just want to take a minute to say that I think that Fleming College made the right call, and this is in the interest of all of our safety. And if these measures seem extreme, that's totally understandable. If they're causing you some stress, that's totally understandable. But look at it this way. We may very well save some lives and save thousands of people from getting sick by taking these extreme measures. So I hope that you can agree that it's worth it. We miss you, and we definitely don't want it to be this way, but we are committed to making it the best it can possibly be. So it's going to be impossible for you to come in and do some monitoring, but we're still going to at least implement experiments and show you what we would have done for the rest of the semester. So starting with week 11 lab, we're going to look at, like I said, vegetative propagation. So this is also known as asexual reproduction. So far, all we focused on is sexual reproduction, which is the growing of trees from seed. So we have parent trees, the male tree or flower pollinates the female tree or the female flower. The ovaries are populated and the seed forms, and we get to grow a whole new tree. One of the major outcomes of that is the new tree has a completely distinct set of DNA from either the male parent tree or the female parent tree. With vegetative reproduction, this looks at propagating a different way. So basically, we're taking clippings or twigs from an existing tree. We just clip this off. We do a little bit of preparation. We stick it in a substrate, and we expect it to grow. And that's how we get a new tree. The main difference between asexual or vegetative reproduction and sexual reproduction or growing from seed is that this new tree will be exactly the same genetically as its parent tree. So if we have certain personality traits, if we have certain traits that are desirable, like good fall color, good form, fast growth, those are the big ones, then we can clone that tree, and all of the little clone babies should have the same beneficial properties. So we have selected a few different species. We've got balsam poplar, we've got willow as well. Poplar and willow are both known to propagate well vegetatively. So we're just going to do a little bit of preparation with these cuttings. We're going to stick them in our mist bed, and then we're going to monitor them over the next few weeks to see what kind of root growth we get. So the other thing we're going to test today is a rooting hormone. So there's a gray powder here. And the idea behind this hormone is it is supposed to help the roots develop. So part of our experiment will be seeing if the rooting hormone actually benefits the cuttings and how much it benefits. So the idea here is we want 1 or 2 year old wood, because essentially there is going to be enough energy stored in the wood to wake it up. We also want some buds, because there should be energy stored in the buds. So we really want to facilitate growth from the bottom so that roots develop, and from the buds so that foliage develops. It's going to be the same sort of process as our seeds. The roots should develop first, and then the foliage develops. So for the species that we are not treating with rooting hormone, all we're going to do is score a little bit of the bottom. Do we have a knife? I'm just going to grab a knife to do that. And all we're doing in scoring the bark is exposing the vascular cambium. So as a reminder, the vascular cambium is undifferentiated tissue. So that means that anything can develop from this, that green area there. That could become shoots, it could become buds, it could become roots. We're going to stick it in dampened substrate and give it the cultural things it needs to encourage root growth there, but what we could find is that any number of things develop. So we want to get about 3 centimeters of shaved bark to expose that cambium. If it's a little less than 3 centimeters, if it's a little more than 3 centimeters, it's okay. The cuttings are fairly lenient for that. So that's what we're going to do for 5 that we're not treating with the hormone. Then we're going to have 5 that we are treating with the hormone, and we're going to try and get different sizes for the 5 and the 5. So the ones that are getting treated with the hormone, we're still going to score the bark all the way to the bottom, and then we're just going to add a couple of extra steps. We're going to dip it in water just to get it nice and damp and sticky, and then we're going to roll it in the rooting hormone. I'll try and let you see this as much as we can. Okay, so it's nicely coated. We're gonna tap off the excess, and we're going to keep the treated cuttings and the untreated cuttings separate. So we're going to get all 5 of those done. We've prepped our tags. So we've got balsam poplar, our species code, our team name, we're all doing this together. So we're WPP Frost. And we've got with the rooting hormone. And we have without for without the rooting hormone. So we're going to scribe the rest of these, then we're going to head out to the mist bed, and we'll show you the process for planting them into their new home.